Going on, guys, let's look at this problem right here. This question is asking find the solution of the given initial value problem, and here we have a differential equation with initial values. And if you look at this differential equation, that is matching with this pattern. This is a linear second order differential equation with constant coefficients. So this also a linear second order differential equation with constant coefficients. And when we have linear second order differential equation with constant coefficient, we can use this characteristic equation to figure out our roots. And to find this one, first we have to find ABC values. ABC values is basically the coefficients of this differential equation. Here A is equal to 1, B is equal to 1, and C is going to be equal to 2. Now we can write our characteristic equation. That's going to be r square plus b is 1, r square plus r plus c is going to be 2 is equal to 0. And if you look at this one, this is not easy to factor. So what we had to do is we had to use this equation to figure out our roots. Now this is x, but in our case that's going to be r. So r is going to be equal to negative b is going to be 1, and plus or minus square root of b square, that's going to be just 1 square, minus 4 times a is 1 times c is going to be 2, divided by 2 times 1. And let's simplify this one. Negative 1 plus or minus square root of 1 minus 8 divided by 2, and 1 minus 8 is going to be negative 7. Negative 1 plus or minus square root of negative 7 divided by 2. Since we are having negative number inside of square root, this is going to be a imaginary number, like a complex number. So complex number have imaginary part and the real part. We have to write it in that way because when we have a complex number, our general solution for the differential equation is going to be this pattern. Y of x is equal to c1 e power alpha x cos beta x plus c2 e power alpha x sin beta x. Now we have to know what is alpha and beta values in order to plug it in this equation, right? Now alpha values is the real number and beta values is the imaginary number. Now to find out, we have to separate this one. So this is going to be negative 1 plus or minus, and instead of this negative 1 inside of the square root, we replace that one with the I square. So when we put I square, that's going to become I outside of the square root, and that's going to be square root of 7i. Okay, and divided by 2, but since we have to find alpha beta, I divide both of them separately. So in that way we can write alpha and beta easily, right? So this is going to be 2, and from this one we know that alpha is going to be this part. This is negative half, and beta is going to be this part. That's going to be square root of 7 divided by 2. Now we can go ahead and write our general solution. General solution is going to be y of x is equal to c1 e power alpha is negative half x, and cos beta is going to be square root of 7 divided by 2 x, and plus c2 again e power negative half x sine square root of 7 divided by 2x, and that's it. Now this is our general solution for this differential equation. Now we have to find the particular solution because we have the initial values. The purpose of the initial values is to find out the particular solution. Now to find the particular solution, we have to find out what is C1, C2 is. To find out C1, what we can, like one of them, what we do is we plug this equation, these initial values. First condition is when y of 0 is equal to 0. Now let's see what happens if we plug 0 for x values. And from this one you can see that y of x is 0 is equal to c1 e power 0, because 0 multiplied by negative half, that's going to be 0. E power 0 is equal to 1, right? C1 times 1, and then cos, this is going to be 0 because square root of 7 divided by 2 times 0, that's going to be 0. So this also going to be 1 because cos 0 is 1. So 1 times c1, so that's going to be just c1. And here we have c2, and again e power 0 is 1, and this is going to be sine 0. Sine 0 is 0. So this is going to be just 0. So from this one we can see that C1 is equal to 0. Now let's see what happened for C2. To figure out C2, first we had to know what's the equation is going to be when C1 is equal to 0. Now let's write that one down. If C1 is 0, this whole thing is going to be 0 because this whole thing is multiplied by C1. So this whole thing is going to be 0. So this is the only thing that's going to remain when y of 0. Okay. So in y of 0, we are going to just have this equation. Let's write that one down. C2 e power negative half x sine square root of 7 divided by 2x. So this makes this problem much easier because we have y prime of 0 here. So we don't have to worry about this part because we know that C1 is 0. So this part is not going to exist. So this is the only part we had to worry about. Like we had to find out what C2 is. To find out, we had to find the first derivative. Now since we have two functions related to x, because we have e power this x and sine this x, we had to use the product rule. Okay, now let's continue this part on top. Here we have y of x. Now we are going to find y prime of x. Let's find the derivative. Now let's find the derivative of this part first. So this is going to be a chain rule because we have outside derivative and inside derivative. Inside derivative is going to be just square root of 7 divided by 2. 7 divided by 2 and then multiply by this one, c2 e power negative half x, and derivative of sine is going to be cos. So this is going to be just cos square root of 7 divided by 2x. Okay, so this is for the first part. Now when we take the derivative with respect to sine, now we had to find the derivative of e power. Now that one is going to be, okay, I shouldn't write equal, this is going to continue, and that's going to be negative because we have negative half in the power. So negative half, that's going to be the derivative of the, this is going to be chain rule also. So derivative of the power, and then c2 e power negative half x, we can write it as x divided by 2, and then we are going to have derivative of sine. Actually sine is going to be cos. Now I'm doing the product rule, so we don't have to touch this one, so we just keep it as it is. That's going to be just sine square root of 7 divided by 2 x, and that's it. Now let's plug 0, and if you plug 0, we definitely know this one is going to be 0 because we have sine here, and if sine 0 is 0, this whole thing is going to be 0. So we only have going to have this part. Now let's see what happens when we plug 0 for x values. So e power 0, this is going to be 0. I mean the e power 0, that's going to be 1. And here we have cos 0, that's also going to be 1. So we are going to have y prime of x is 0 is equal to 2. So let's plug that one. 2 is equal to square root of 7 divided by 2 c2. And from this one we know that c2 is going to be 4 over square root of 7. So this is our c2 value. So the particular solution for this differential equation is going to be here. Let's write this one right down here. Y of x is going to be c2, we figured out, that's 4 over root 7. 4 over root 7 e power negative half x sine square root of 7 divided by 2x, and that's going to be the particular solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.